Hello everyone and welcome to day 19 of the Jamb Physics in 40 Days series. It has been an incredible series so far, and thank you to each and everyone who has been following the series from the very beginning, from day 1 to day 19. It's been incredible. Thank you so much. And please keep your questions coming. If there's anything you would like to tell us, or if there's any question you came across during your study and you would like us to shed more light on, so please put it in the comment section and we'll definitely attend to all of your questions. And also, please don't forget to like, share, and subscribe. Please, let's try to reach as many who are really in need of this series, because we believe that when you truly dedicate within 30 to 45 minutes of your time daily, you will be well on your way to ace Jamb Physics. So please share it to as many who definitely need this video. And if you're new to this series, I will believe that when you dedicate your time to follow this series from day 1 till the end, you should be able to gather all the necessary skills that will help you ace Jamb Physics. So if physics is one of the subjects that you have chosen to write in the Jamb exam, so please check out the videos from day 1. We have been able to look at different topics from the Jamb Physics curriculum. In each of our videos, we discuss those topics, what is expected of you, and then we go on to solve past questions on those topics. So you do not want to miss any one of the videos in this series. So please check it out and ensure that if you have any question, please drop the question. We will definitely attend to it. And also, to help you practice more, you can always try the Exam Fun app. The link to download the app is going to be added to the description box of this video. So just click the link and download the app, where you get to practice multiple questions on any subject of your choice. And it is created in such a way that it makes your learning experience fun-like, because you get to answer questions at different levels, and you see your performance even as you go, and then you get to learn in a fun and friendly environment. So please download the app today, and also don't forget to subscribe to the channel. Now, to the business of day 19, we're going to be looking at heat transfer. And what is expected of every Jamb candidate as far as heat transfer is that you should be able to explain what conduction, convection, and radiation are. Now, these are the modes by which heat is transferred. Now, we have the conduction, which is when heat is transferred by the molecules, individual molecules in the particular material, from one to the other, from the hotter region to the cooler region. And in the case of convection, we have the heat being transferred by the actual movement of the heated molecules from the hotter region to the cooler region. And then in the case of radiation, is the transfer of heat by invisible electromagnetic radiation. And in this particular mode of heat transfer, the intervening body is not heated up. It just goes through that vacuum without heating up the intervening medium. Now, another thing that they expect is that you should be able to calculate temperature gradient, thermal conductivity, and heat flux. They also expect that you should be able to tell the effect of the nature of the surface of an object to the energy they radiate and the energy they absorb. Like when an object is polished, does it radiate more energy or does it absorb more energy? Things like this help us to even choose make options, rather, when we are picking, like for example, if you want to buy your car and you live in a region where there is a lot of heat. It helps you because the color of your car also adds to the nature of the surface of what we are talking about and how it absorbs and radiates heat energy. For example, darker colors tend to absorb more heat energy, and while the brighter colors radiate more. So as a result, if you have a dark colored vest or a clothing in a hot region, you're going to feel a lot more hotter, because the black material is going to continue to absorb more heat energy and keep it on your body. Whereas when you wear colorful clothing, they radiate more of the heat to the atmosphere back. So that way you don't keep heat on yourself. That's why I see those who live in places that are very hot tend to wear clothing that are brightly colored. Especially the closer it is to white, the better it is. Whereas when you are in places where it's cold, it's better to wear dark clothing as they keep your body heat on you, and that way you can be warm even in a cooler region. Another thing that is expected of you is you should be able to explain the conductivities of some common materials like conductivity of copper, conductivity of aluminium and the likes. And then you should also be able to explain land and sea breeze. This is actually an evidence of convection current in nature, where you see that during the day when the sand is more heated, the heat that is retained by the sun tends to heat up the atmospheric air, and then they move up and then to the sea, and then they continue in that direction from land to the air to the sea. So the cooler breeze on the sea will come to land. So when the cool breeze from the sea comes to land, we call it sea breeze. That's what happens during the day. But at night, we have what we call land breeze, where the sea is slightly warmer than the land, and then you see that cool breeze from land goes to the sea, and then the warmer air on the sea goes to the atmosphere, and they continue in that direction. That one is called land breeze. So the JAMB expect that every candidate should be able to explain these parameters and use it to answer questions. And then finally, they expect that you should be able to solve problems involving combustion engines as well, as they explain heat transfer. So having looked at what is expected of you, let us go on to look at some questions that has been set in JAMB in time past and answer them, and also give you tips to solve problems on heat transfer. Now, the heat from the sun reaches the earth by the process. Now, this is asking us the process by which heat from sun will reach earth. And this is a method of heat transfer whereby the heat is moving from the hotter region to the cooler region through a vacuum. Now, most importantly, we also see that the vacuum itself is not heated, right? So that is, the intervening medium does not receive the heat. So this is a method of heat transfer known as radiation. So the option we go for here is going to be E. Two closed vessels contain equal volume of boiling water and are identical, except that one is blackened on the outside while the other is polished. So which of the following is correct? Now, this is going to depend on how well they radiate or absorb heat. Now, it's important to note that a black surface is the best radiator, just as it is the best absorber of heat energy. So that is, when you place two materials like this, where one is blackened, the other one is polished, the one that is blackened is going to lose heat the fastest, and is also going to gain heat the fastest, depending on what you are doing. So if you are heating it up, it's supposed to gain heat fastest. But in this case, they are going to be losing heat because they have equal volume of boiling water. So they should be losing heat. So the black one should lose heat fastest. So let's see which of the options tells us this. Now, A says the polished vessel will cool faster. Now, this is not true at all, because we know the blackened one is supposed to cool faster. Now, B says the polished vessel will cool faster because it will absorb less heat from the room. Now, the ability to lose heat does not depend on what the surrounding, but rather based on the surface. So, and it's supposed to be that the black one is supposed to lose heat faster because it's going to radiate more. Now, C says the black vessel will cool faster because it reflects heat better. The black vessel will cool faster because it reflects heat better. And then D says the polished vessel will cool faster because it reflects heat better. And then E says the black vessel will cool faster because a black surface radiates heat faster than a polished one. Now, E is the most likely option because the black vessel is going to radiate most of the heat energy it has. So that will make it to cool faster. Now, it's a better option than option C. So therefore, we go for option E. Consider a thick glass tumbler and a thin glass tumbler, which are made of the same kind of glass. Now, some hot liquid is poured into them. Now, which of the following statements is correct? Now, when you have two glass tumblers, one thing is certain: when you pour hot liquid into glass tumblers, they're going to expand. And due to uneven expansion, remember that glass is a poor conductor of heat energy. So because of this uneven expansion, it will cause the glass to crack. However, there is a difference between that of the thick and the thin glass tumbler. So let's look at the options and pick the one that is correct. So A says the thick tumbler is less likely to crack because it is stronger. Now the reason why it is going less likely to crack is not because of the strength. So therefore A is not correct. Now B says the thick tumbler is less likely to crack because it insulates heat better. Yes, they are poor conductors of heat, but it's still going to expand due to heat. So therefore, this also does not explain why the thick tumbler should crack and it should be less likely rather to crack. Now, option C says both tumblers are equally likely to crack because they are made of the same material. Now, yes, they are going to crack. They are likely to crack rather, but one will crack faster than the other. So that makes option C also wrong. Then finally, option D says the thick tumbler is more likely to crack because of uneven expansion persists for a longer time. Now, this is true. The uneven expansion is also known as stress. Due to this thermal stress, the thermal stress is going to last longer in the thick glass compared to the thin glass. So as a result, the thick one is less likely to crack as compared to the thin one. The moment you pour the hot liquid into the thin one, it is most likely going to crack as immediately as you pour the hot liquid. Whereas the thick one is still going to take the heat for a little longer than the thin glass tumbler. So the correct option here is D. A hot metal ball is suspended in open air. As it cools, it loses heat by. So when you take a metal ball suspended in air, now remember this is what? Hot metal ball. Now what's going to happen is that the surrounding air around it, as they pass by, will begin to carry off some of the heat of this metal ball. So you see that the molecules of air around it are moving the heat from the hotter region to cooler region, and that is what describes convection current. So in this case, the heat it loses is due to convection only. So we go with option B. The vacuum in a thermos flask helps to reduce heat transfer by. Now, when you consider a thermos flask, it is often made with a vacuum between the inner wall of the thermos flask itself and the outer wall. Now, this is to actually eliminate heat transfer by conduction and convection. Now, if you consider conduction, it relies on the ability of the molecules to transfer heat as they contact each other. Now, because there is nothing between the inner wall of the thermos and the outer wall, there is a vacuum between them. Because of this, heat transfer cannot occur by conduction. That one eliminates conduction. Now, if there were air in that same part, just like in the case of the question where we answered, where you have a ball hanging in space like this, you see that the air around it was able to take away the heat from the metal ball, right? But in this case, it is a vacuum, which means there is no air, so nothing will also take away the heat by convection. So that eliminates convection. However, radiation can still occur because that one can happen in a vacuum. Now, the only way you can limit radiation from reducing the heat in the thermos flask is by making sure that the walls of the inner walls rather of the thermos flask is silvery. Now, when it is silvery, that means it's going to reflect radiant heat energy. It will not allow it to pass through. So that way, you can also eliminate heat transfer by radiation. But this question is talking about the vacuum, the purpose of the vacuum, not the silver surface of the inner walls of the thermos flasks. So we are going to limit this to just convection and conduction. So the correct answer here is option B. This question says that ice cubes are added to a glass of warm water. Now the glass and the water are cooled by. Now let's consider this to be the glass of warm water. And then ice cube right there in it. You know it's going to float because it's less dense at this point. So by the time it begins to melt, something is going to happen. First, the heat that is in the glass and the warm water will be transferred to the cooler ice by conduction. But that's not just what happens in this case, because as this ice also melts as a result of the heat that is being transferred by conduction, the cold iced water that is melting off this ice, which is more dense than the warm water, will begin to sink to the bottom, while the warm water itself will rise to the top. So you see there's going to be a circulation there where cold water is going to the bottom and warm water is coming to the top. And that is how convection current goes, where you begin to exchange cold for warm, and it continues like that until we get to an equilibrium temperature. So we see conduction happening, and we also see convection current happening in this case. So we would say the answer is conduction and convection, which is option C. This question says the radiator of a motor car is cooled by, and then we have options such as radiation, conduction, convection, radiation, and convection. Now, this question itself can be a little bit tricky if you don't understand what the question really means. Because when you consider the radiator of a motor car, right, as the engine of the car is working, cool water needs to circulate through to cool down the engine so that it doesn't overheat. So when it goes through it, it has to come back through the radiator so that that water that has gone to cool down the engine can then be cooled a little bit before it goes on and circulates to go on to cool the engine again. And that system keeps going over and over as the car walks on, right? But the question is not asking us how the water is getting cooled, because that would have been convection easily, right? But it is asking how the radiator itself gets cooled. And when you consider the engine carefully and you see the radiator, you see that behind it there's always a fan, right? And as the car walks on, the fan cools down the engine by blowing some cool air across it. So you see there that the process by which it is cooled is by convection, as cool air comes and passes through the radiator and then takes away some of the heat, and then the system continues like that. So it's convection current by air. So our answer here is going to be option C. The blade of a hoe feels colder to touch in the morning than the wooden handle because. Now, to understand what really happens here, let's not just consider the hoe, but any other material that is made of metal or stainless steel. Like take for example this big spoon we use during cooking, right? You see that it is made of metal, but the handle is made of either plastic or wood. Now, this is to ensure that while you are cooking or stirring hot food, the heat that is conducted by the metal spoon does not get to your hand and burns it. Now, this is because the metal spoon itself is a good conductor of heat, but the handle, which is either made of rubber or wood, is a poor conductor of heat. So it is unable to conduct heat to your hand. So that way your hand remains cool while the spoon is really hot. The same thing is the case with the hoe. The wooden handle is unable to conduct heat during the hot hours of the day. So which is why it's going to remain at that temperature that it is. But the metal handle during the day would get really hot because of the presence of heat. But by the time it gets to the morning time, most of the heat that is on the metal blade would have been conducted away. So at that time, it becomes really cool to touch. Whereas the handle is unable to conduct heat, so it remains at whatsoever temperature it was all along because it's unable to remove the heat that is on it. Whereas the blade has taken away all the heat that it holds. So that is why you see that the metal handle of not just a hoe, but anything made of metal feels cold to touch in the morning. This is because they have conducted away all the heat that is on them. So the answer is that the blade is a better conductor of heat than the handle. And that is what we see in option C. So we go with C. Heat is radiated by hot objects in the form of. Now, those of you who are very familiar with war movies and things like that, you may have seen scenes where you see soldiers holding a type of scope to their eyes to view enemy lines. And then they see this reddish hue kind of visualization of people. when they see people walking through, they see them in reddish hue, not like in the normal visible way you will see a person, right? And the same thing happens when you are looking at the Natural Geographic channel at night. Sometimes you see when they are trying to sense whether there are animals in burrows or things like that. They use that same type of camera where you can see those animals glowing in reddish color, right? This is because the humans in this case and the animals in the case of the Natural Geographic channels are the type of they are called warm-blooded animals, right? Which means that they have heat signatures on their body because they emit heat. And the same thing happens to every object that has a large energy of heat on them. They emit that heat energy, and you can be able to view this using the infrared cameras. That's because the heat is actually radiated in form of infrared. However, it's important that I also mention that when you heat up metal objects, especially to a certain level, they get so hot that they begin to glow, right? That glow you see is not infrared, it's visible light. So yes, they can also radiate visible light, but in a majority case, the heat that is radiated from hot objects comes in form of infrared, which is why you can also sense it with a thermometer that you don't have to put in contact with the body. Like during the time of the coronavirus or the time of the Ebola virus, you see that type of thermometer being in use a lot because you don't want to touch people who may have been infected. So they use it to sense the wavelength of the infrared that they emit, and by that they can tell the temperature just by the color of the infrared. So you see there, hot objects emit infrared. So our answer here is option C. Which of the following has no effect on radiation? Now, before I go on to answer this question, if you're yet to follow the channel, I want to implore you to please do so. It's only going to take a second of your time. You just have to hit the subscribe button. We need you all to subscribe to the channel so that we can be able to continue to make more helpful videos like this. So please subscribe, and also you can hit the notification bell icon so that you get notified when we put out new content. And please, if you have any question perhaps concerning the videos we are making, or you come across a question during your study time and you like help with it, so please put those questions in the comment section and we will definitely attend to all your questions. And I also want to hope that you are practicing with the Exam Fund app. If you are not doing that yet, you can find the link to download the app in the description box of this video. Please click the link, download the app, and practice with the Exam Fund app. I promise you it is an exciting app for you because it makes your learning experience more like a game-like format where you answer questions in different levels and progress and earn points, scores, and even some money. So please download the app and spice up your reading time, spice up how you study by using the Exam Fund app today. Trust me, you're going to love it. Now, to answer this question here, we are looking at what has effect on radiation. So we have to pick the one of these options that does not have any effect at all on radiation. Now, when we look at option A, we see the nature of the surface. And one of the things that we have learned so far is that a black body radiates more heat, right? So that tells you that the nature of the surface is really important, as black bodies radiate more heat while polished or silvered bodies radiate less heat. So in that case, nature of the surface has effect, so it is not our answer in this case. And if we consider the other options too, we will see that surface area affects just as temperature also affects, leaving us with density. In the case of surface area, a body that has a larger surface area will radiate more heat than a body with a lesser surface area. And in the case of temperature, we can pick that from the Stefan Boltzmann law, which actually tells us that the more the temperature, the more heat that is radiated by a body. So we see that A, C, and D have effect on radiation, but density does not have any effect on radiation, though it actually influences conduction and convection. But as far as radiation goes, it has no effect. So our answer is B. The main reason for making the cover of a vacuum flask airtight is to prevent heat loss by Now, if the cover were not airtight, what will happen is that since it cannot lose heat from the sides, and the only way it can lose it is from that cover, right? So that means the cool air that blows over the cover would collect some of the heat and take it to cooler regions, and then the circle continues like that. So you see that it's by actual movement of the air molecules that blow over the cover, right? So that is convection. So the answer here is A. Heat transfer by convection in a liquid is due to the. Now, when we consider the options that we have here, there's an argument that can be made for almost each of these options provided. However, we have to focus on which of them is actually the main reason, or should I put it, the key reason why heat is being transferred by convection in liquid. Now, when you heat up a liquid, something is going to happen. As you heat it up, the density of that liquid begins to reduce as the temperature is shooting up. So that is, the relation between temperature and density is inverse proportionality. So as temperature rises, density falls. And now it's not the entire density of the liquid that falls immediately, but the density of the liquid that is closer to the heat falls faster than those at the top. So it means there's going to be variation in the density in the entire liquid. Let's say this is the pot now, right? Filled with water to this point, and then I apply my source of heat here. So the liquid that is closer to the heat here becomes less dense faster than those at the top here. And what we do about density is that, especially in liquids, they are going to be stacked based on their density. Like for example, if you pour kerosene into water, the kerosene will float because it is less dense than water, right? So the same thing happens here. The less dense liquid that is here closer to the heat will then rise to the top, so that the more dense liquid will fall to the bottom. And this continues because as the more dense comes to the bottom, it is being heated up and it becomes less dense again and then goes to the top, and then that cycle continues and on until the entire liquid becomes really hot and less dense than it was before. So the main reason why we see heat transfer by convection in liquid is because of the variation of the density of the liquid. So we'll pick our answer as option C. Take a minute to look at this question where you are asked when an athlete perspires after running, he loses heat through, and then you have four options: evaporation, conduction, radiation, and convection. Now, which of these options do you really think it is? Now, the answer to this question lies actually in this line. An athlete perspires after running. Now, perspiration means that the athlete is, in simpler English, is sweating, right? So when the athlete sweats, you see water all over the body of that athlete. Now, as that water evaporates, it takes away heat from the body of the athlete, leaving him cooler and cooler as time goes on. So the way this athlete loses heat is by evaporation. I hope that's what you chose too. So that will be option A. The time rate of loss of heat by a body is proportional to the. Now, this is the opening line to what is known as the Newton's law of cooling. So to complete it, let's state the Newton's law of cooling so that we can always remember it. So the law states that the time rate of the loss of heat of a body is proportional to the difference in temperature between the body and its surrounding, provided that the difference in this temperature is not too large. So that would be the condition to the Newton's law of cooling. So the remaining part of this that we have to find from the option is in option C, where we see difference in the temperature between the body and its surrounding. So our answer is option C. The statement heat lost by the hot body equals heat gained by the cold one is assumed when determining the specific heat capacity by method of mixtures. Now, which of the following validates the assumption? Before we look at the ones that we have been given here, let's consider the statement in itself. Now, during method of mixtures, if you would see with the calculations we made, especially when we're studying the specific heat capacity, we made that statement a lot. right? Now, one of the things that you always have to ensure when you are doing this experiment of method of mixture is that you have to limit the amount of heat energy that is given to the surrounding. You want to ensure that the heat stays within the experiment and not shared with the surrounding. So let's now look at what we are given and then pick the correct answer from that. So one, we have lagging the calorimeter. Now this is going to limit the heat that is shared with the surroundings. So it will keep the heat within the experiment. So this validates the experiment, or the statement rather, that heat lost by the hot body equals the heat gained by the cold one. Now, the second statement says ensuring that only SI units are used. This is only necessary in the case of calculations and does not necessarily affect exchange of heat. So it does not validate it. Now, number 3 says weighing the calorimeter, the lead, and the stirrer. Now, since we are trying to find the specific heat capacity of a body, the mass is very important in this case also, yes, but it does not necessarily affect the statement. It's only useful in the case of the calculation. The question is not asking us which one affects the calculation. It's saying which one validates the statement, not the calculation. Just the statement that heat lost by the hot body equals the one gained by the cold body. So in this case, it's only lagging the calorimeter that validates the statement. So we are going to go with I only, which is in option A. Now, you can practice more with many more questions that are available on the Exam Fund app. If you do not have the app yet, you can find the link to download it in the description box of this video. So kindly click the link, download the app, and spice up your reading time, as the Exam Fund makes your learning experience a fun one by giving you multiple questions in a game-like environment where you solve questions at different levels, endpoints, and even get some money. So please download the app today and enjoy your learning time with Exam Fund. And also do not forget to subscribe to the channel. We need you to subscribe so that we can continue to make more helpful videos like this. So hit the subscribe button and the notification bell icon so that you get notified every time we put out a new content. Thank you very much for following this series. I'll see you in the next one.